In this screencast, we're going to talk about correlation and regression. So the purpose of correlation and regression is to show the relationship between two quantitative variables, one called an explanatory variable, which we usually use the variable x for, and a response variable y. And the idea is that the explanatory variable explains or predicts the response. So for example, we want to predict the price of a house based on its size, or the price of a used car based on how many miles it has on it, or a student's college GPA based on their ACT scores. So in these cases, the explanatory variable is the size of the house, the mileage of a used car, or the ACT score, and the things we want to predict, or the response variable, price in the first two cases, and college GPA in the third. So first we'll talk about correlation. Here we see a scatter plot showing how the size of a house and the price of houses in a small Wisconsin community are connected. So what are we seeing here? Well, here's some small homes, 1,500, 1,400 square feet here, and priced more modestly, $150,000. This is priced in thousands. Here we have big homes. This is 2,200 square feet, and it's priced at $300,000. And up here we have very big homes. The largest one here is 4,500 square feet, and it's priced at $500,000. So here we see a relationship between the size and the price, and it's a pretty regular relationship. It's pretty strong. Sure, in any size area there's some variation, but knowing the size of a house tells you something about how much it's likely to cost. On the other hand, here's a scatter plot showing size versus how long the house has been on the market for those same homes, and there's no particular relationship here. It's just all muddy. You've got small homes that have been on the market for 200 days. You've got mid-sized homes that have been on the market for 200 days, and you've got the big home has been on the market for 200 days. Nothing going on here. So we measure this. We measure how strong those relationships are with the correlation coefficient, sometimes called Pearson's R. It's a measure of the strength and direction of the linear relationship between two quantitative variables. How strong it is, what direction it is, and how well it fits a line, the linear relationship. So first of all, the correlation coefficient is always between -1 and 1. That's a mathematical necessity. If R is close to -1 or close to +1, that's a strong relationship. Close to 0 indicates a weak relationship. In our cases, in our two scatter plots, for the size and price of homes, the correlation coefficient was 0.91, so that's quite strong, which is what the scatter plot told us. For size and days on market, it's 0.19, which is quite weak. It really doesn't tell us much of anything. It looks like random variation. Now, this is an interesting scatter plot because the relationship between x and y is very strong. If you know x, you can predict y perfectly, but you still got a small correlation coefficient because it's not linear. So correlation coefficient really tells you how closely a straight line fits the scatter plot, or how close the points in the scatter plot can be approximated by a straight line. How about the sign of R? So R could be positive or negative. What does the plus or minus tell us? Well, a positive relationship means that the bigger the explanatory variable, the bigger the response variable. Larger houses cost more. That's a positive relationship. On the other hand, a negative relationship is just the opposite. The larger the explanatory variable, the smaller the response variable. The more miles there are in a used car, the less they cost. So here we see a negative correlation. In fact, it's negative 0.88. So these are the miles on a used car and versus the price. And just as we'd expect, the more miles on the car, the less it costs. In my PowerPoints, I remind you how to find these things in Excel, but there's separate screencasts that will take you through the process. This is just so you have it written down if you need to refer back to it later. So here's some examples of correlation coefficients so we can begin to get visuals for them. In these 6 examples, if you can sort of see these, then you'll have a good idea of what's going on when you look at scatter plots. Here, There's nothing particular going on, very weak negative correlation, negative 0.05. Second one, very strong and positive, 0.96. This is weak and positive, about 0.71. So they call it weak. I would call it moderate myself. That seems to me like a moderate relationship. But 0.71, you get much below that, and it doesn't begin to look like much. Here's again, basically no relationship. Looks like a big cloud. Here's a strong negative relationship. So correlation coefficient is negative 0.92. And then here is again a weakish or moderate one, but more on the weak side, negative 0.45. So you ought to be able to look at a scatter plot and get have a general idea of what the correlation coefficient is, whether it's positive, negative, strong, or near zero. And there is a formula for correlation coefficient, but we're not going to talk about it, or maybe we'll talk about it in class. Okay, and in the next screencast, we'll turn our attention to linear regression.